Okay, for Unit 7, we have this preliminary drawing to look at, and we've seen this now a few times. Obviously, this is 0, and the unit circle goes to the right 1 and up 0. And then as I divide by bigger numbers, as we know from division, the answer is smaller. And our denominators of 6, 4, 3, and 2 are what we've become used to. So this is our 30-degree angle, 45-degree angle, 60-degree angle, and 90-degree angle. And since this x has to be bigger than the y, the root 3 comes first, the 1 comes second. Here, the x is smaller and the y is bigger, so the 1 comes first and the root 3 comes second. By now we know everybody's divided by 2. And then the 45-degree angle is all about root 2. And then to go straight up, we don't go left to right anywhere, but we go up 1. And if you can do the first quadrant, then you can do the other 3. So for example, if this is 1/3, this is 2/3, and if this is 1/6, this is 5/6, because 6/6 will be the 180 or pi. And then if this is 1 pi over 2, 1 pi over 4, 2 pi over 4, this is 3 pi over 4. And you use the same numbers as these, except you have to change the positive and negativeness because you're now in the second quadrant. So then in the second quadrant, the x's are going to be negative, but the y's stay positive. You could use that same thinking to fill in the other 2. You can do this now for practice or move on. So this is Unit 7, Day 1. And here, in example 1, we have here the sine graph, which we've done before. And we know from previous experience that the period is 2 pi. In general, it's 2 pi over b, but b is 1, so it's 2 pi over 1, just 2 pi. The x-intercepts are at 0, at pi, 2 pi, 3 pi, 4 pi. So it's a variable pi, but the variable has to be an integer. And then where is it 1? Well, it's 1 at pi over 2. It's 1 at 5 pi over 2. So it happens at every period. So it's pi over 2 plus 2 pi k every 2 pi, a period. And again, k has to be an integer. So sine is a half when the y is small and the x is big. So this is our pi over 6 angle. And because the period is 2 pi, I can keep going around and around, end up in the same place. That's what this is all about. But sine is also positive in the second quadrant. That's this angle. And if this is 6 pi over 6, this must be 5 pi over 6. And again, every 2 pi k, we always have to say k is an integer. Here sine is negative root 2 over 2. When sine is negative, y is negative. The root 2 means I have that 45-degree angle here and the 45-degree angle here. Well, the 45-degree angle is with over 4, so this is 4 pi over 4. So this must be 5 pi over 4, 6 pi over 4, 7 pi over 4. Sine is negative in these third and fourth quadrants. And so 5 pi over 4 every 2 pi k as I go round and round and round. And the same is true for 7 pi over 4 plus 2 pi k. Here is our cosine graph. The period gives again 2 pi. The x-intercepts are here and here and here, which are pi over 2. And the next one over is not a full period, it's like half a period. So if the full period is 2 pi, half a period is pi, and again, it's every integer multiple of pi. -1 is down here, and down here, and down here, so that's at pi, and this does occur at every period, so plus 2 pi k, k again is an integer. Just as a reminder for cosine, where the big number is on the top, cosine is x. When x is big, that means it's the flatter angle, x is big, and so this is at pi over 6. But remember, cosine is positive in the first and fourth quadrants. So then down here, this is 2 pi or 12 pi over 6. That's how we can write 2 pi. This is 1 less than that, so 11 pi over 6. That's how I remember it. And so those are the two angles in the first and fourth quadrants. And again, every period I can go round and round and round and have the same coterminal angle. Here is our tangent graph, but remember for tangent the period was pi, not 2 pi. So we want to talk about when is tangent 1. Well, tangent is 1 here, or 1, the y value is 1, here and here. So this is pi over 4, and it's every period past that, every pi k. So when is tangent root 3? Well, tangent is y over x, so the big has to be the y, that's the root 3, and the x has to be 1. And if I go down here into the third quadrant, I can have -1 and negative root 3. The y over the x will still be root 3. So then this is the big angle, the 60-degree angle, pi over 3. And then to get to the angle into the third quadrant, I can add pi, add pi, add pi, add pi, and I can get to both of them because the period is pi. I don't have to worry about 2 pi.